On this Ram 1500 with the 5.7 Hemi, P0135 points to an O2 sensor 1/1 heater performance problem. In plain terms, the PCM may be commanding the upstream oxygen sensor heater and not seeing the heater respond the way it expects. The driver may only notice the MIL, but this kind of fault can also affect how quickly the sensor gets ready after startup. Broadly, think possible heater control circuit resistance, heater ground circuit resistance, the sensor heater itself, connector problems, or, after the rest of the path checks out, PCM involvement. Start with the basic system checks before getting into the pinpoint testing. For the diagnostic logic, treat the enable criteria as the monitor gate. This diagnostic runs with the engine running, battery voltage between 11.0 and 15.75 volts, no ambient air temperature sensor fault set, and one of the temperature gates satisfied. Engine coolant temperature at startup is above 7 degrees C 44.6 degrees F. Ambient temperature is above 7 degrees C 44.6 degrees F. The difference between coolant temperature and ambient temperature is greater than 9 degrees C 16.2 degrees F at engine start, or the O2 sensor heater temperature is greater than 401 degrees C 753.8 degrees F for more than 20.0 seconds. The set logic is command versus response. The PCM detects that the difference between the actual O2 sensor heater element resistance or temperature and the target resistance or temperature is not within a calibrated threshold with the O2 sensor heater duty cycle above 89.8% for 90.0 seconds. First, check for any applicable service bulletins or PCM flash updates related to P0135. If one applies, handle that repair path first, then verify the repair and confirm the code stays gone. If nothing applies, move on to the active heater operation test. Next, use the scan tool to check whether the fault is active. Turn the ignition off and wait a minimum of 8 minutes so the sensor can cool down. Before continuing, the sensor voltage should stabilize between 2.47 and 2.52 volts. Then turn the ignition on. Actuate the oxygen sensor 1/1 heater control with the scan tool, and monitor O2 sensor 1/1 voltage for at least 2 minutes. The decision point is whether the voltage stays above approximately 4.5 volts. If it does, keep going. If it does not, treat it as an intermittent condition and follow a structured diagnostic approach for that condition instead of forcing the rest of this path. After the active test, check the recorded codes. If other O2 sensor heater circuit codes are present, diagnose those heater circuit faults first. If there are no other O2 sensor heater circuit faults pointing you elsewhere, continue with the O2 sensor 1/1 heater element resistance check. Now check the O2 sensor 1/1 heater element resistance. Turn the ignition off, let the heater cool down from the scan tool test, and disconnect the O2 sensor 1/1 harness connector. Measure across the sensor on the component side, between the O2 heater control terminal and the heater ground terminal. If possible, make the measurement at approximately 20 degrees C, 68 degrees F, because the resistance changes with temperature. The acceptable range shown is 0 degrees C, 32 degrees F3, 1.4 ohms, 20 degrees C, 68 degrees F3, 3.4 ohms, and 100 degrees C, 212 degrees F3, 85.5 ohms. The maximum allowable resistance would be 12.5 ohms at 1000 degrees C. If the resistance is in range, go to the ground circuit load test. If it is not in range, first verify good pentaterminal contact at the O2 sensor and PCM harness connectors. If no connector problem is found, replace the O2 sensor, then verify the repair and confirm the code stays gone. Next, load test the Z908 ground circuit for high resistance. Disconnect the component harness connector to isolate the ground circuit. Connect the positive lead of the load test tool to the positive side of the battery and the negative lead to the ground circuit at the component harness connector. The bulb should be illuminated and bright if the circuit is not carrying excessive resistance. Compare it to a direct battery connection. If you have to work at a PCM connector, do not probe the PCM harness connectors directly. Use the GPEC Diagnostic Adapter 10436. A 3156 bulb has approximately 6.0 ohms of resistance when the bulb is powered and draws approximately 2.0 amps of current. A 12-volt test light can be substituted only if it draws enough current to effectively load test the circuit. Many high-impedance test lights draw very little amperage, less than 0.1 amps, and are not reliable to load test a circuit. To perform a proper load test, the tool should draw more than approximately 0.75 amps. As an example, 2.0 ohms of resistance in the circuit being tested will cause the voltage measurement across the bulb to be 25% less than when compared to battery voltage. The reason is that the 2.0 ohms in the circuit makes up 25% of the total circuit resistance of 8.0 ohms. Also remember, the GPEC diagnostic adapter can add up to 1.5 ohms of resistance to the circuit. If the bulb is bright, move to the heater control circuit. If it is not bright, repair the ground circuit for an open or high resistance, then verify the repair and confirm the code stays gone. Then isolate and load test the O2 sensor 1/1K99 heater control circuit for high resistance. The ignition must be off for this load test. Isolate the circuit by disconnecting the ECU and every component harness connector that contains the circuit being tested. Connect the positive lead of the load test tool to the positive side of the battery. Using an approved back probe tool, connect the negative lead to the circuit at one component connector. Then use an approved back probe tool and a fused jumper wire to connect the same circuit to battery negative or a known good ground at the other component connector. The bulb should again be illuminated and bright, and there should be no continuity between ground and the circuit being tested. Use the same load tool logic here. A 3156 bulb has approximately 6.0 ohms of resistance when the bulb is powered and draws approximately 2.0 amps of current. A 12-volt test light can be substituted only if it draws enough current to effectively load test the circuit. Many high-impedance test lights draw very little amperage, less than 0.1 amps, and are not reliable to load test a circuit. The tool should draw more than approximately 0.75 amps. The same example applies here. 2.0 ohms of resistance in the circuit being tested will cause the voltage measurement across the bulb to be 25% less than when compared to battery voltage because the 2.0 ohms in the circuit makes up 25% of the total circuit resistance of 8.0 ohms. The GPEC diagnostic adapter can add up to 1.5 ohms of resistance. Do not load test any circuit with components still connected. Also, do not use this load test method on airbag or restraint system components or circuits. If the bulb is bright, continue to connection checks. If it is not bright, repair the circuit for an open or high resistance. Then verify the repair and confirm the code stays gone. If the sensor element, ground circuit, and heater control circuit all pass, inspect the related PCM inline and component connections. Disconnect the PCM connectors, any related inline connectors, and the related component connectors. Look for connector installation problems, damaged locks, corrosion, water intrusion, whether seal damage, bent terminals, overheated or discolored terminals from poor connection, push-back terminals, spread terminals, and poor terminal tension. Repair any conditions found. Then reconnect everything fully, making sure the connectors are seated and the locks are engaged. Erase the codes, test drive or operate the vehicle under the monitored and set conditions, and read the codes again. If P0135 returns after those checks, replace and program the PCM, then verify the repair and confirm the code stays gone. If the code does not return, the wiring or poor connection problem has been repaired, and you still finish with repair verification. The clean way through P0135 is to prove the heater command response first, then check for related heater circuit faults, verify the heater element against temperature, load test the ground and control circuits, and only then make the call on connection repairs or PCM action. For more diagnostic training, visit stepdiagnostics.com.